Hi, I'm Bob. Welcome back to the Solutions to Microeconomics course. I use the textbook Microeconomics Theory and Applications with Calculus, the 5th edition, by Professor Jeffrey Perloff. Today, we will solve the exercises in the comparative statics part of Chapter 2. It is about how a demand or supply shock affects the equilibrium price and quantity. Comparative statics is the method economists use to analyze how the goods price and quantity react to a change in environmental variables. Environmental variables are the factors that researchers do not control and are not determined by the model studied. So they are also called the exogenous variables. By contrast, the goods price and quantity are the endogenous variables we examine in the model. Let's go to exercise 4.1. Use a figure to explain the fisher's comment about the effect of a large catch on the market price in the cartoon about catching lobsters in this chapter. What is the supply shock? The supply shock is good luck or an unexpected increase in the number of lobsters in the ocean that causes a large catch of lobsters. The supply shock shifts the supply curve to the right from S1 to S2, indicating that the quantity of lobsters supplied increases at any given price. The demand curve is unchanged, so the market equilibrium moves from E1 to E2. The equilibrium price falls from P1 to P2, and the equilibrium quantity rises from Q1 to Q2. Let's do exercise 4.2. The 9/11 terrorist attacks caused the U.S. airline travel demand curve to shift left by an estimated 30%. Use a supply and demand diagram to show the likely effect on price and quantity. Indicate the magnitude of the likely equilibrium price and quantity effects. For example, would you expect the equilibrium quantity to change by about 30%? Show how the answer depends on the shape and location of the supply and demand curves. With a normal supply curve that slopes upward, the equilibrium quantity is expected to fall by less than 30%. The shift of the demand curve to the left from D1 to D2 causes a movement along the supply curve from E1 to E2. The equilibrium quantity falls from Q1 to Q2, which is less than 30%, and the equilibrium price falls from P1 to P2, which is also less than the shift of the demand curve. The reason is due to the shape of the curves. In the second case, where the supply curve is much flatter, the equilibrium quantity falls nearly by 30%, and the equilibrium price falls only slightly. In the extreme case of a horizontal supply curve, where the quantity supplied is extremely sensitive to price changes, the shift of the demand curve causes a 30% decrease in equilibrium quantity, but has no effect on the equilibrium price. In case 3, on the contrary, we have a vertical supply curve. The shift of the demand curve causes the equilibrium price to fall substantially, but has no effect on the equilibrium quantity in this case. Let's look at exercise 4.3. Production of ethanol, a fuel made from corn, increased more than 8.5 times from 1.63 billion gallons in 2000 to 15.8 billion gallons in 2017. Use a supply and demand diagram to show the effect of this increased use of corn for producing ethanol on the price of corn and the consumption of corn as food. The demand for corn rises because of the increased use of corn for producing ethanol. The demand shock shifts the demand curve to the right from D1 to D2. If the supply curve slows upward, then the equilibrium price rises from P1 to P2, and the equilibrium quantity increases from Q1 to Q2. Since the increase in the equilibrium quantity is smaller than the shift in the demand for corn, that is, the increase in the equilibrium quantity is not enough for the use in production of ethanol, the consumption of corn as food must fall. Let's do exercise 4.4. The demand function is Q equals 220 minus 2 times P, and the supply function is Q equals 20 plus 3 times P minus 20 times R, where R is the rental cost of capital. How do the equilibrium price and quantity vary with R? We already have the demand and the supply functions. The supply function contains an environmental variable R. In the first step, we find the equilibrium price and quantity. At the market equilibrium, the quantity demanded equals the quantity supplied. We can solve for the equilibrium price P star. Substituting it into the demand or the supply function gives the equilibrium quantity Q star. In the second step, we differentiate the equilibrium price and quantity with respect to R. As the rental cost of capital increases by 1 unit, the equilibrium price rises by 4 units, and the equilibrium quantity falls by 8 units. Let's find answers to exercise 4.5. Due to a recession that lowered incomes, the market prices for last-minute rentals of U.S. beachfront properties were lower than usual. Suppose that the demand function for renting a beachfront property in Ocean City, New Jersey, during the first week of August is Q equals 1,000 minus P plus Y divided by 20, where Y is the median annual income of the people involved in this market, Q is quantity, and P is the rental price. The supply function is Q equals 2 times P minus Y divided by 20. In part 1, derive the equilibrium price P and quantity Q in terms of Y. At the market equilibrium, quantity demanded equals quantity supplied. We have the equilibrium price and quantity in terms of the median annual income Y. In Part B, use a supply and demand analysis to show the effect of decreased income on the equilibrium price of rental homes, that is, find dP over dy. Thus, a decrease in median income leads to a decrease in the equilibrium rental price. We differentiate the equilibrium price with respect to y and get 1 over 30, which is positive, It means the equilibrium price moves in the same direction as the median income. So a decrease in median income leads to a decrease in the equilibrium rental price. Let's do exercise 4.6. Suppose that the daily market demand for cigarettes in New York City is Q equals 20,000 times P minus 0.4, and that the market supply curve of cigarettes in the city is a horizontal line at a price P which equals 1.5 times PW, where PW is the wholesale price of cigarettes. In Part A, assume that the New York retail market for cigarettes is competitive. Calculate the equilibrium price and quantity of cigarettes as a function of the wholesale price. Let Q star represent the equilibrium quantity. Find dQ star over dPW. The demand function is as follows. The demand curve is downward sloping. The inverse supply curve is P equals 1.5 times PW. It is a horizontal supply curve. So the equilibrium price P star equals 1.5 times PW. Substituting the equilibrium price into the demand function gives the equilibrium quantity Q star. Then we take the derivative of Q star with respect to PW. We find that the marginal change is a function of PW. In Part B, New York retailers pay a tax of a total of $5.85 per pack. Using both math and a graph show how the introduction of the tax shifts the market supply curve. How does the introduction of the tax affect the equilibrium retail price and quantity of cigarettes? The introduction of the tax is a supply shock. It raises the cost and shifts the supply curve upward by $5.85. From the graph, we find that the equilibrium price will rise by $5.85, and the equilibrium retail quantity will fall. We can also see it using math. The equilibrium retail price function is as follows, where tau is the tax. The derivative of P star with respect to tau is 1, implying a 1-to-1 increase in the equilibrium price. The equilibrium quantity is as follows. The derivative of it with respect to the tax is negative, implying a decrease in the quantity in the market equilibrium. In Part C, given the specific tax, calculate the equilibrium price and quantity of cigarettes as a function of wholesale price. How does the presence of the tax affect dQ star over dPW? In the first step, we plug in the tax value and calculate the equilibrium price and quantity. In the second step, we take the derivative of the equilibrium retail quantity with respect to the wholesale price and compare it with the one without tax. We find that the former is smaller than the latter in absolute value. So the wholesale price PW has a less negative effect on the equilibrium quantity Q star with the tax. Let's solve exercise 4.7. Given the answer to exercise 2.4, what effect does a U.S. quota on steel have on the equilibrium in the U.S. steel market? It depends on whether the quota binds. If the demand is low, as shown in D1, then the quota has no effect on the equilibrium price and quantity. If the demand is high, as shown in D2, then the quota will increase the equilibrium price and decrease the equilibrium quantity. We can see it clearly in the supply and demand diagram. E1 is the equilibrium without the quota. E2 is the equilibrium with the quota. E1 has a higher price and a lower quantity than E2. Let's do exercise 4.8. Suppose the demand function for carpenters is Q equals 100 minus W, and the supply curve is Q equals 10 plus 2 times W minus T, where Q is the number of carpenters, W is the wage, and T is the test score required to pass the licensing exam. By how much do the equilibrium quantity and wage vary as T increases? In the first step, we calculate the equilibrium price and quantity. At the market equilibrium, the quantity of carpenters supplied equals the quantity of carpenters demanded. The equation gives the equilibrium price, that is, the wage. Substituting it into the demand or supply function, we have the equilibrium quantity. They are functions of the test score T. In the second step, we differentiate the equilibrium price and quantity with respect to T. As T increases by 1 unit, the equilibrium wage increases by 1/3, and the equilibrium quantity decreases by 1/3 units. Let's do exercise 4.9. Use a figure to illustrate the wage and quantity effects of the opioid as described in the application, the opioid epidemic's labor market effects. Here is the supply and demand diagram. The opioid epidemic caused the labor supply curve to shift to the left from S1 to S2. Suppose the labor demand is unchanged. As a result, the equilibrium quantity of labor fell from Q1 to Q2, and the equilibrium wage rose from W1 to W2. Let's find answers to exercise 4.10. Use calculus to illustrate how increased use of opioids, O, affects the equilibrium quantity of labor, L, as described in the application, the opioid epidemic's labor market effects, dW over dO. The labor demand function is L equals dW, where L is the hours of work demanded and W is the wage. The labor supply function is L equals S WO, where L is the hours of work supplied. We use the chain rule to solve this exercise. The quantity demanded is a function of wage, and the quantity supplied is a function of wage and the use of opioids. We write down the equilibrium condition equation at the market equilibrium. Remember that the equilibrium wage W star is a function of the use of opioids, O. In the first step, we differentiate the equilibrium condition equation with respect to O using the chain rule. Rearranging the equation, we have the expression of partial W star over partial O. We know that partial D over partial W star is negative because of the law of demand. An increase in the wage leads to a decrease in the demand for labor. The labor supply curve is usually upward sloping. the supply of labor increases with wage. So the denominator is negative. Thus, partial wage over partial O has the opposite sign as partial S over partial O. In the second step, we use either the demand or supply function to determine the effect of the use of opioids on the equilibrium quantity of labor. I apply the chain rule to the labor demand function. Since the equilibrium wage is a function of O, we have two parts on the right-hand side. Because partial L star over partial wage star is negative by the law of demand, partial L star over partial O has the opposite sign as partial W star over partial O, or the same sign as partial S over partial O. We know that the use of opioids reduces the labor supply. That is, partial S over partial O is negative. Then we can conclude that the increase in the use of opioids reduces the equilibrium quantity of labor, which is consistent with the graph in the last exercise. Let's do exercise 4.11. The study concluded that a revolution in the video game market, better games with a lower price, dramatically increased the amount of time young men spend playing video games and shifted their labor supply curve. In 2015, young men played video games for 3.4 hours per week on average. From 2000 through 2015, average annual hours of work for men aged 21 to 30, excluding full-time students, dropped by 12%. Suppose the labor demand function is L equals 200 minus W and the supply curve is L equals 40 plus W minus 2 times V, where L is the hours worked, W is the wage, and V is a measure of the quality of video games. By how much do the equilibrium hours and wage vary as V increases? In the first step, we solve for the equilibrium hours and wage. In the second step, we take the derivative of the equilibrium hours and wage with respect to V. As V increases by 1 unit, the equilibrium wage increases by 1 unit, and the equilibrium hours of work decrease by 1 unit. Let's solve exercise 4.12. Bentonite clay, which consists of Asian volcanic ash, is used in kitty litter, to clarify wine, and for many other uses. One of the major uses is for drilling mud, a material pumped down oil and gas wells during drilling to keep the drilling bit cool. When oil drilling decreases, less bentonite is demanded at any given price. The price of crude oil was about $50 a barrel in 2016 to 2017. However, by 2018, it was over $70, causing drilling to increase. Use a supply and demand diagram to show the effect on the bentonite market and explain in words what happened. The increase in oil drilling raises the demand for bentonite clay. It shifts its demand curve to the right. Suppose the supply curve is unchanged. The shift of the demand curve causes both the equilibrium price and quantity to rise. Thank you so much for solving the exercises with me. See you soon in the next part of Chapter 2. Goodbye. Thank you for watching this video and subscribing to my YouTube channel. See you next time.